So let us now calculate the electric field due to a dipole, electric dipole at any point lying on its equatorial line. Very easy article. So again, plus q charge, this is another charge minus q, this is a point, this is b, separated by a distance of 2a. Center, this is center. This line is called equatorial line. Let us suppose there is a point P at a distance r. Now join this line. The electric field of this charge, if I are taking in magnitude, is given by kq upon this distance. By Pythagoras, since it is 90 degrees, so Pythagoras it will be r square plus a square. So electric field kq upon r square plus a square. Direction this side. Similarly, the electric field due to B, it will be kq upon, join this. If you join this, again test charge plus attract toward negative, formula will be again same. Now one side is this side, another is this side. If I resolve these two components, one will be EA along I cap, EA along J cap. Similarly, this EB, this side will be EB I cap and this side will be EB minus J cap. Or you can say if it is theta, this is also theta. Resolve two component, this side will be cos theta and this side will be sin theta and this side is also sin theta. But if you add this, answer will be 0. If you add, magnitude is same but direction is opposite. So resultant electric field is given by, it will be given by EA cos theta plus EB cos theta. Since magnitude of EA and EB both are equal, so resultant electric field will be twice of E cos theta. So it is twice of E. What is E? kq upon r square plus this. The column is cos theta. Check carefully. If this angle theta, this is also theta. You can see in this diagram. What is cos theta then? Base upon hypotenuse. So base is what? It is this. Hypotenuse is r square plus a square. So electric field is kq into 2a divided by, yes, divided by r square plus a square 3 by 2. But you know that what is P? P is q into 2a, is called dipole moment. This is same here. Same as here, q into 2a. So this may be written as kp upon r square plus a square 3 by 2. This is the answer. Yeah. And so that's it. This is the end of this. Now write a note. There is another term, short dipole. And the condition for a dipole to be short, that r is greater than a, so that a is approximate 0. We know that on axial line we found expression that was 2 Kapoor r square minus a square ka whole square. But for short dipole, a is approximate 0. Therefore, E axial will be equal to 2 kp upon r ka cube. Similarly, if we come for equatorial, it is kp upon r square plus a square 3 by 2. But for a short dipole, what is a 0? If you put, you get kp upon r cube. And if you compare these two, what do you get? You get E axial is twice of E equatorial. This is the case for a short dipole. This might be MCQ in board exam. But remember this thing. So after this, the last and the most important concept comes the torque. Expression for the torque acting on dipole in uniform electric field. Torque, very simple article, very easy article. So consider uniform electric field represented by these arrow. You know that these arrow represents the direction of electric lines of force. This side is positive, this side is negative. Let us suppose this dipole is placed. This is the dipole. If this is dipole, let us suppose this is minus q, this is plus q, since it is a system. And these two charges separated by a distance of how much? 2a. Let us suppose this dipole makes an angle theta. I call this point as a A and this point as a B. Now drop a perpendicular. If you drop a perpendicular, this is called, I call this as C. Now when a dipole is placed in electric field, this charge will experience a force which is given by Q into E in this side. This charge will also experience a force QE but in this side. Both forces are of equal magnitude but opposite in direction. Now you know that if this is a couple, one force on this side, another this. If it is a couple, then moment of couple is given by moment of couple. Then moment of couple, or sometimes it is called torque. So what is the formula to calculate torque? You know that either force multiply what perpendicular distance between their line of action. That perpendicular distance here is AC. Now force is Q into E, either magnitude into AC. Now see this triangle, and this triangle ABC. If you find sine theta, what is sine theta? Is perpendicular bata. What is perpendicular? Perpendicular AC. Hypotenuse 2a. So from this AC will be equal to 2a sine theta. Let us put here. Therefore torque will be equal to QE into, or it might be maybe written as E Q into 2a then sine theta. ये बच्चे आ गया फिर से. What is this? This is called dipole moment. So formula is 2pe sine theta. So formula is 2pe sine theta. What is p? P is q into, now it is a vector quantity, so it may be written as p cross e. You know that in case of cross product, the direction is given by that rule, right hand thumb rule, or tau is always perpendicular to the plane containing P and E. This is electric field. So here there are two cases arises. Number one, if theta is 0, sine 0 is 0. In that case, torque will be 0. Sometime question comes in exam, represent this diagrammatically. अब डायग्राम में कैसे when I say theta is 0, it means the angle between dipole moment and the electric field is 0. And you know that the direction of dipole moment, negative to positive. So this side is dipole moment, this side is electric field. Angle is 0. Second case, if theta is 90, then sine 90 is sine 90 is 1. In that case, we say that torque is maximum. And it is P into E. So what will be this case? This is electric field. This is the electric field. So this is my minus Q or plus Q. This angle is, so this is a CBSE question that represented diagrammatically. So we can represent this diagrammatically. The last article is that I want to find work done in rotating the dipole. Do you place the dipole? The torque will act. When the torque will act, BE sin theta, try to align in the direction of applied electric field. So if I want to disturb, I will do some work. When it is in equilibrium, net force will be 0, net torque will be 0. To rotate that dipole, I will do some work. That work then stored in the form of 1 mark question, potential energy. तो मेरे को डाइपोल मेरा इक्विलिब्रियम था, इक्विलिब्रियम से मैंने उसको शिफ्ट करना है, So I will do work done. Work done is given by tau into d theta, since I am giving angular displacement, not the translation equilibrium. Put the value tau PE sin theta into d theta. This is the work done. अभी मेरे को इसको रोटेट करना था. Total work done can calculate by integration of PE sin theta into, स्टार्टिंग मैंने करा थीटा 1 पे था, बाद में उसने जब इंटेन किया तो थीटा 2. टेक P outside, E inside. Inside is integral of theta 1 to theta 2 sine theta d theta. What is integral of sine theta? Very easy. Sine theta integral is minus cos theta. Upper limit minus lower limit. So it comes out to be minus, or if we take inside negative, so it may be written as cos theta 1 minus cos theta 2. This work done is stored in the form of potential energy. Now if I suppose in starting that this torque is maximum, so this is a special case. If in starting theta 1 is 90 and theta 2 is theta, it is aligned with some angle, in that case the work done will be equal to minus PE cos theta. Now here arises the most important question, that there are two types of equilibrium: stable equilibrium unstable equilibrium. Stable equilibrium, what is the condition for stable equilibrium? Theta should be 0, so that the work done, which is stored in the form of potential energy, is given by this. Unstable equilibrium, theta should be 180, so that work done is minus PE cos 180 is minus 1, so work done is plus P into E. So these are very important for the point of view of CBSE. So many time question asked from this, that under what condition it will be in stable equilibrium or unstable equilibrium. So my last topic is that what happens if a charged particle moves inside the electric field. Let us suppose this is plus side, this is negative. My charged particle enters plus. What will happen? It will move to this side. I want to find the trajectory of this charged particle when it moves on this side. So coming with some initial velocity. So very easy. I know that V equal to U plus AT, or deflection is given by S equal to UT plus half AT square. Initial velocity, if I am taking 0 starting, acceleration is AT square. What is A? Acceleration. Now when charged particle Q enter in the electric field, force will be act Q into E, but force is mass into acceleration. So acceleration is QE by M. So S, or deflection, that I call it as S, is 1 by 2 QE by M into T. T is what? T is the time to move from this to this side. Now I know that velocity is distance by time. From this time will be equal to distance by velocity. What distance it will cover? What distance it will cover? So it may be x by v ka square. So s is proportional to x ka that deflection. So its path will be that's and thank you very much.